I recently purchased a buck converter board to reduce the voltage from a 22-volt battery to a 12-volt regulated output. Ever wondered what are these components on the board? Let's look at that. Here is the buck converter circuit diagram. We have the input voltage, which in this case is the battery input. We have a capacitor for the input for reducing the voltage ripple when the switch switches. We have a diode. There's an inductor for reducing the current ripple. There is a capacitor for reducing the output voltage ripple. And the load is shown as a resistance. Now there is another buck converter topology which is very similar to this. It has a small difference, but it causes a big change in the performance of the system. So we still have the input voltage, the capacitor, the switch, the inductor, the output capacitor, and the load resistance. Instead of the diode, we have a switch now, which is a MOSFET. So what happens because of that? The loss in the diode in the previous topology is equal to the forward voltage of the diode multiplied by the current flowing through that. In the second topology, the loss in the switch is the resistance of the switch multiplied by the current. Apologies for using R instead of P for the loss. Now because this RS2 resistance is lower than the forward voltage, we get much lower losses, and that allows the converter to run at a much better efficiency. This is a synchronous buck converter. Now let's look at the components on the actual board. Drawing the circuit again. The red and the black wires on the left are the input voltage from the battery. Those two large components are the capacitors, which are the input capacitance. Now one of the most important passive components on the board is this large square in the middle, and that is the inductor. This reduces the ripple in the current flowing through the system. The capacitors on the right of the inductor are the output capacitors. These are for reducing the ripple on the output voltage. And the two wires are the wires leading to the load. This IC is one of the most important components in the system. This IC contains the switches, the control logic, so both switch S1, S2, and all the circuit associated with controlling the voltage of the system. Let's look at this in detail. This chip is an LMR51420. Looking at the block diagram, we have the input voltage, a ground connected to that, and we have some of these other resistances that are required for that. Now these two resistances, which are resistance divider, are used for sending feedback of the output voltage back to the IC. What this does is that this feedback allows the IC to regulate the output voltage. And so depending on the voltage it gets back, it adjusts its duty cycle to control the output, which allows this chip to be a variable output voltage buck converter. So we can change the resistance values, change the feedback voltage coming back to it, and that allows us to work at a different voltage level. And that is where all the feedback resistances are. Now this small capacitor that we see is a very important circuit component. It is what is called a bootstrap capacitor. This capacitor charges every switching cycle and allows the higher side MOSFET to turn on. The higher side MOSFET basically requires above Vin voltage to switch on, and so the bootstrap capacitor is very important for that. So these are all the components that go on a buck converter board. Thank you very much for watching. Please mention in comments if you would like to see any of the details of the buck converter board. Thank you.